Okay, so we are starting with our second part of this chapter. This is evaluating exponential expressions. So once again, instead of just simplifying them, now we're going to evaluate them, which means that we are going to substitute in values for our variables, and we'll be able to get much closer to an actual answer for these expressions. So let's start with n to the negative 3, w to the 0, and we are going to evaluate this for n equals negative 2. I don't know if I keep leaning over, if my voice actually stops carrying into the microphone. I'll fix that next time. And w will equal 5. So here is our expression, n to the negative 3, w to the 0, and our values are n equals negative 2 and w equals 5. So what I'm going to recommend always on these is to go ahead and simplify the expression first. Don't start throwing the values in until you have simplified the expression. So we're going to simplify this first. Now, the one thing that I want you to remember is, although in the first lesson I said that any number to the power of 0 equals 1, I also want to go further with that and say any variable to the power of 0 equals 1. So basically what we're looking at here is just a 1, and so therefore it is not going to affect our expression and the valuation of it at all. So now we're going to look at this n to the negative 3, and we're going to understand that that is 1 over n cubed. Okay, so now we have a simplified form, and we are going to now put our variables in. So this is now going to equal 1 over, and now notice we have a negative 2 for our n. So I'm going to put the negative 2 in. I'm going to put it in parentheses because I want to show that the entire value of n, the entire negative 2, will be cubed. Okay, so 1 over, and now I am going to cube the negative 2. So we know that 2 times 2 times 2 is 8. When we are cubing with a negative, remember we have got negative times negative equaling a positive, and then a positive times a negative equaling again negative. So our answer is going to be negative 8. So here is the value of that expression, 1 over negative 8. Okay, so let's go ahead and look at another. We're going to be keeping these values for our variables, and we have n to the negative 1, and that is going to be over w squared. So once again, my suggestion is we first simplify the fraction that we have here, realizing that w is extremely happy where it is, but the n is not. The n does not belong in our numerator. So we are going to say this should be 1 over n, and we can put that it's to the first power. We typically don't write that. We'll put it there just now so that we can just remind ourselves that yes, indeed, we have already worked with that, and we have w squared. Now we're going to go ahead and we're going to put those values in. So we have 1 over, and for n, we have this negative 2. Okay, we are not going to put that it's to the first. We already know that we have taken care of that. And w, of course, is our 5, so that's going to be 5 squared. So this is going to be negative 2 times 5 squared. So going back to PEMDAS, always having to remember PEMDAS, we have to do our 5 squared first. So we have 1 over negative 2 times our 25. And we'll go down to the next line, 1 over, and we have negative 2 times the 25, which gives us negative 50. So our answer here is 1 over negative 50, or negative 1/50th, however you would like to say it. We can look at another problem. We are still going to keep our n equals negative 2 and our w equals 5. We're still maintaining that as we work. And this time we are going to do 1 over, and our denominator, n w to the negative 2. Okay, so first thing we are going to do, once again, is simplify this fraction or this exponential expression, however you would like to say it. And we are going to say that this n, no exponent, so therefore we know that it has an exponent of 1 because we don't see it. They don't write it when it's a 1. I'm putting it there so that we know we've discussed it. Okay? And this w has an exponent of negative 2. The w is not where it belongs. So when we simplify this so that we have no negative exponents, we're going to put w squared up top over our n. And now we will go ahead and we will put our values in. So this becomes 5 squared over negative 2. And when we go ahead and we square that, we've got 25 over a negative 2. We can go a couple of different ways with this. Let's go ahead and just convert it to a mixed number and fully simplify this fraction. So this will actually give us a negative 2 will go into 25 12 times with 1 left over, and our denominator is 2. So our answer here is negative 12 1/2. Okay, so this is how we evaluate these exponential expressions. The last part of this section before we are done will be a real-world problem solving. So let's go ahead and get ourselves a fresh page, and we will look at the real-world problem. And what we are dealing with in the real-world problem, let me just get it in front of me so that I actually can read it and not have you lose my voice, although I think it would be very hard to completely lose my voice. I have a sample of bacteria that triples each month. The expression 5,400 times 3 to the power of m models this population of 5,400 bacteria. That is our 5,400 bacteria. And after m months of growth, m months. So we are letting that m equal our months. Let m equal our months of growth. Evaluate the expression. So we are going to be evaluate for m equals negative 2 and for m equals 0. Okay. And then we will describe what each value of the expression represents afterwards. Now, this word problem is on page 432 of your book, bottom of the page, at the bottom. So if you want to kind of follow along with the wording, maybe re-look at the words and kind of compare what we're doing here with the words that they are talking about. So we know that this bacteria triples each month. Okay, so first we're going to look at m equals -2. So let's just put that -2 in for m. So we have 5,400 times 3 to the -2. Okay, so we should understand by this point that 3 to the -2 is actually 1 over 3 squared. So this is actually going to be 5,400 over 3 squared. So it's actually being divided in this instance. So we have 5,400 divided by this 9. Well, if we just look at it without these zeros, we know that 54 divided by 9 is going to be 6. 6 times 9 is 54. So when I simplify this, 5,400 divided by 9 is 600. So what do we mean by 600? Well, what we're looking for, what we're saying is that the population is 600 2 months before the population is 5,400, because we've got that -2. So, so we're looking at, you know, it was 600 2 months ago. Note the -2 brought us earlier. So you would say that, you know, in another month, this would triple. When you triple 600, that's going to give you what, 3 times that is 1,800. And then it would triple again, and that's where you get your 5,400. So, so this is 2 months prior to when it was 5,400. Now let's evaluate it for m equals 0. So now we've got 5,400 times 3 to the 0 power. Well, that's basically saying 5,400 times 1, which is equal to 5,400. So what we're talking about here is actual current time. At this point in time, we're at 5,400. We are at 0 hour at this point. So, so I hope that this is all pretty understandable as far as the word problem. What we are basically doing is just replacing that exponent with the values that they give us. But what they do want you to look at is, what does it mean? What are they talking about? So, hopefully you'll be able to run through this video a couple of times, take notes on it, make sure that you understand everything. We will discuss the lesson briefly, but I will answer questions in the morning, and then we will get right to work on working problems. I hope this was understandable, and thank you.